All right, we're going to take another look at trig equations because, of course, now we've got some more identities and relationships that we can use to help us solve them. So this is a typical sort of one we saw earlier. Cos of 2 theta is equal to a half. And what we did before is we said, all right, well, we'll look for answers for 2 theta, but because theta is going between 0 and 360, we're going to look for answers that go around twice. We're going to look for answers between 0 and 720. So we know we're in quadrant 1 and quadrant 4, and we want to find our acute angle. So the acute angle is 60 degrees. So our possibilities then for 2 theta, well, first quadrant, it'll be that acute angle. Fourth quadrant, 360 minus the acute angle. So it'll be 60, 360 minus 60, but that only gives us the first two answers we're looking for. So then we add 360 to both of them. But that's the answer, of course, for 2 theta. We want 1 theta. Divide by 2, and then all our answers now fall between the requirement of 0 and 360. So, okay, that's how we handled that question before. Of course, now we've got another way of writing cos 2 theta. We could rewrite cos 2 theta and say, hey, that's 2 cos squared theta minus 1. And solve that particular one. So now cos squared becomes 3/4. Cos is plus or minus. Now there's the biggest mistake when people use this method. They forget about the plus or minus. So because it's plus or minus, we're going to be in all 4 quadrants. So again, just like our answer over here, we are going to end up with 4 answers because of 4 quadrants. So all 4. Find the acute angle. In this case, it turns out to be 30 degrees. But that then gives us alpha, 180 minus alpha, 180 plus alpha, 360 minus alpha. We get the same 4 answers. So our new trig identities, relationships, allow us different ways of solving the same equation. By all means, the first way is still fine. There's nothing wrong with it. But you might now prefer to use the second way. Okay, sec squared, or 4 sec squared rather. 3 equals 3 tan x plus 5. Well, that's using one of our old trig identities, isn't it? We'll change our sec squared to 1 plus tan squared. Creates a quadratic equation, which nicely factorizes for this one. So I've got 2 possibilities, minus 1/4 or 1. Over here, 1 tan negative, second quadrant, fourth quadrant. Let's find our acute angle. To the nearest minute, 14 degrees 2. So my 2 answers for the first part of the question, 165.58, 345.58. Now I'll go do the other one. That's one of our exact values, of course, tan x equals 1. First quadrant, third quadrant. It's the exact value for 45 degrees. So there's our 2 possibilities over there. When I've got 2 possibilities, I think it's nice to write a final statement where you combine all the possibilities together and say, okay, well now I know all the answers are, and I tend to like to write them in numerical order. I think it just looks neater that way. All right, now cos 2 theta 4 cos squared minus 2 sine squared. I got 3 choices for cos 2 theta, of course. Which one to use here? Well, I got cos squareds and sine squares, so I suppose it doesn't really matter which one I use. Which one did I go with? I went with cos squared minus sine squared. So let's play around with that. The reason I did cos squared minus sine squared is I knew I was going to get this situation where on one side of the equation I was going to have cos squared, the other side I was going to have sine squared, so I could create tan squared. Alternative way I could have done it, I could have said cos 2 theta was 2 cos squared theta minus 1, and then on the other side change the sine squared to 1 minus cos squared and have everything in terms of cos squareds. Or of course I could have done the same thing with sine squareds. Again, just a personal choice how you solve it. So I've ended up with tan theta, again, remember plus or minus root 3. So we're expecting 4 answers here. We're in all 4 quadrants. And we want to find our acute angle, also one of our exact values, 60 degrees for this one. So in all 4 quadrants, we end up with 60, 120, 240, 300. Cos 2 theta equals sine theta. I seem to be using cos 2 theta a lot. This one comes from the 2000 paper. I suppose the logical one to use for this one will be the 1 minus 2 sine squared. Get everything in terms of sine. Is that what I did? Yes, I did. So 1 minus 2 sine squared is sine. Let's create a quadratic equation. Does that factorize nicely? Yes, it does. So two possibilities, sine theta is a half, sine theta is -1. So looking at the half, first quadrant, second quadrant. Acute angle, again, another exact value. Sine theta is a half, 30 degrees we're talking about, aren't we? Yep, there it is. And of course, the other one is a boundary value, -1. So there's only one solution for that. That's 270 degrees. On that note, remember with trig equations, another one of the common mistakes. If 0 is a solution, so is 360. Because they're normally going to say in between 0 and 360. And so people remember to write down 0 and think, oh, well, I've got that solution. But of course, 360 is the same solution as 0. So if you see 0 come up, 360, write that one down as well. Don't forget that solution. And so we have 3 answers for this one. All right, this one, wow, that's old, 92. 2 sine squared is sine 2 theta. Don't really have a choice there. We've only got one formula for sine 2 theta. So let's change that to 2 sine theta cos theta. Again, it's a quadratic equation. So let's move to one side and factorize. And don't forget, sine theta equals 0 is a possibility here. There's another common mistake. People just solve the parentheses. Oh, sine theta minus cos theta. Forget about the sine theta out the front. So we do have the possibility of sine theta equaling 0. But our other possibility, sine theta could be cos theta. So that's what I was talking about. 0 is a solution, so 360 is as well. Sine is also 0 at 180. Those are our boundary values. Sine theta equals cos theta. Oh, you should know this off by heart, really. When is sine theta equal to cos theta?
That's wrong.
Got to be 45 degrees. Complementary ratios, remember? Adds up to give 90, so got to be 45. But let's do it the long way. We could turn that into tan theta equals 1. So we're in quadrant 1, quadrant 3. Sure enough, our acute angle turns out to be 45. And so there's our next 2 solutions. So our overall solutions, there we go, 0, 45, 180, 225, 360. 2D is the exercise we'll be going for